In this video, we're solving a projectile motion problem where a projectile is launched into the face of a cliff, and we're given the initial speed and we're given the distance from the cliff. But this is a little bit of an unusual question because what we're trying to calculate in part A is actually the launch angle required for this projectile to hit the cliff in exactly 2 seconds. So the key to this is to realize that I have a distance to the cliff face of 35 meters. I have the time it takes to hit the cliff face, and that immediately tells me what the x component of the velocity is. Remember that that's just a constant in projectile motion. So it's really a distance equals rate times time problem in the beginning. And then once we have that x component of the velocity, I can visualize that over here as a component of the original velocity vector. And then I've got a hypotenuse of a right triangle and the adjacent side allowing me to find the angle. So let's get that kinematics part of it done first. And there's my equation for the x coordinate of a projectile. The acceleration is 0 there. So it's basically telling me distance equals rate times time. I'm assuming that my origin is located at the launch position. So my initial x value is 0. And then I have a final x value of 35 meters. I have a time until the impact of 2 seconds, and I solve for my constant x velocity. This gives me 17.5 meters per second. And again, that initial x velocity is equal to the final x velocity because the x velocity never changes. So then just to make things more clear, I'll blow it up a little bigger. I have this initial launch speed of 30 meters per second. The angle is unknown, but I know that the x component of that velocity is 17.5 meters per second. Then I can say the cosine of this unknown angle is going to be the adjacent side, 17.5 over 30. So the launch angle I need to hit the cliff face in exactly 2 seconds is the inverse cosine, the angle whose cosine is 17.5 over 30. Into 3 sig figs, I get 54.3 degrees out of this. In part B, we're asked to show the projectile hits the cliff on the way up instead of on the way down. And the key to this physically is to calculate what's the y velocity at the moment of impact. And if that's positive, we're still on our way up. And if it's negative, we're on our way down. So I've got to start this by finding the y component of the initial velocity. And that's going to be 30 times the sine of that launch angle, 54.3 degrees. And when I run the numbers on this, I get about 24.4 meters per second. Then I use my y velocity equation for projectile motion. That's Vy is equal to V naught y minus gt, where g is about 9.8 meters per second squared. And I get a 24.4 meters per second positive for my initial y velocity. And then I have minus 9.8 approximately meters per second squared for g. And then the flight time was 2 seconds. And when I run the numbers on this, I get a final y velocity of positive 4.76 meters per second. And that means the projectile was still on its way up. And we're done with that part. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left. Or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.